Warning: if you intend to use the CNC machine, you have to be aware of the hazard associated with moving parts and sharp tools. If you continue to watch this video, you agree you will make the necessary safety arrangement to protect yourself and the people around you. Protection such wearing safety goggles, dust mask. This tool is not suitable for children. Hello. We're gonna do some PCB engraving today. So this is the PCB, blank PCB, and now what we need to do, first of all, we need to change the drill bit to this one. So we use this Allen key to loosen the spindle. So I got only one hand, so oops. And now we need to change this V-shape engraving bit or milling bit to this just standard drilling bit. I'll come back to it when I do it. I use this spanner to loosen the choke, so I'll come back when I change the drill bit. We changed the drill bit, now we need to secure it. So using this same Allen key, we need to secure the spindle. Spindle is secure. The idea now is just to secure this temporary as it is now with a double-sided tape, and you're going to drill I think 6 holes here. I think 6 holes later on we're going to secure the PCB to the working area, so that we're going to start doing the engraving. But at the moment I got a file which was going to be used, or the CNC going to use it to drill 6 holes on the PCB. Now we took the tapes top side off. Now we're going to stick this one to I need two hands. The board now is secured. So this is I'm going to load up the file I created already to drill 4 holes. I'll call it where is it? Where is it? RV CNC project. So somewhere here. Where is that? Okay. Yeah, this file here. So call it PCB mounting drill. So I'll load it up. So it's just going to be basically drilling 4 holes. This is the software which control the CNC machine. We will know a bit how does it now work. I'm going to tell you a bit about the machine. So this is the machine, or the CNC machine itself. So you got your, can you see this is your y-axis. So it's moving up and down like that. That's the y-axis. That's the tools holder. So the tools holder can go up and down in this direction. That's the y-axis. Can go in this direction. That's the x-axis, and you can go up and down in this direction, which is the z-axis. The CNC machine is powered via this power supply. This 12 volt, I think, 5 amps, and that's the CNC controller. It is basically USB to kind of parallel port. I'll just take it off. So that's the UC100, and you work with this machine. And when it is on and functioning properly, you got this green LED on and this blue LED on, and then it's connected to the PC, and it's connected to the PC. The spindle, which is this bit here, that has its own power supply, 230 volt power supply, is connected to this here, these two. So one for to power the CNC, and one to power the spindle. You got this here to change the speed rotation of the spindle, and it goes up to 20,000 rotation per minute. So the CNC accessories, we've got this rail here to secure this rail here. They've got two rails, one here and one here. This is to secure the thing you're working on. At the moment we got this wooden piece. We use this wooden piece when we are working so we don't damage the CNC bed. I got the CNC bed aluminium, but at the moment we're using this not to damage the tools, and when we get used to it and become a semi-professional, we can just put the aluminium bed. What else I need to tell you? I need to tell you also we got this emergency button here, and this emergency button is useful if you need to stop the CNC machine in case of an emergency. This will only stop the motors and the CNC machine itself, but it's not gonna stop the spindle, because the spindle is directly powered via the socket over there. So in case of emergency you need to hit this one and you stop immediately the CNC, and you need to turn off the power of the spindle. So as I said, the CNC is connected to the PCB via the USB, and this is the software which control this. Not this one. I don't know. This is the software which control the CNC machine. It's just a standard graphic interface, where it does have a lot of feature, but we're more interested in for example this one. If you want to move the y-axis, and you can hear the moving y-axis up and down, similar. This is going down, and the x-axis you can move over along the x-axis, up, left and right, and also you can control the z-axis. So I'm using the mouse at the moment, and I can select where I want to go. Come back here, we're going. So this is the speed. So if I put 10, you'll notice that going very slowly, and this is useful when you want to adjust your tools, mainly for example to find the 0 x and the 0 on y, and also to set the height of your tools to 0, the height of your tools. So you change the speed here accordingly what you want to know. So now it's going a bit faster. You can also use the keyboard arrows. So that's up and down. So that's the y axis. I'll do it again. And then the left and right. That's the x axis. And up and down on the keyboard. Oh, come on, where's it going? Up and down on the keyboard is affecting the z-axis, so you can up and down. As I said before, if you don't want to go fast, you need to come here and change the speed. Then same. So you're moving slowly. So also you have this X, Y, Z, and he show you the actual position of the tool, X, Y, Z. So if I move it a bit, and you can see the coordinate is changing up and down. This is A, B, C, D, C. This is if you add another tools, but at the moment we're just using one tool. When you want to set your 0, you position your tools wherever you want to position it, somewhere on the PCB. So I'm just going to go a bit faster, so I'll come here again, put 0, so I've got a bit faster. Then I'll reduce the speed to 10 for example, because I need to find my position 0 now. I'm unhappy with that position. That's my 0, that's my starting 0, that's my reference 0. So I will come here and for example x0, z0, no, x0 and y0, and the z0 we do it differently. We need to position the z-axis in a way that this is going to be the z0. This one here, if you want to send a G-code, so let's go back again just for the sake of the experiment and load my file. So I'll load my G-code file, and that's my G-code file. We will do we'll drill 6 holes along the PCB. At the moment my 0 is somewhere, then I need to set it up. As I showed you before, to set it up I'm just going to play with the arrows on the keyboard or using just the mouse. So I need to do, for example, I can see it's a bit, I want to set it up about here. That's going to be my 0, so it's a bit far away, so I will go fast a bit. So I'm going the wrong way. So pressing this one here, roughly that one. Then I need to go on the X, change the XY, roughly that way. Now I need maybe I need to pull the down a bit. So I need to reduce the speed now, and okay, you can see I got more controlled movement. So I'll move it a bit until I'm happy with the. So I think that's the X. Okay, oh, sorry. I need to down it a bit. Okay, I think I'm happy with that. That's corner, so it's my 0. So I set my 0 now in the corner. So I need to, that's the physical position of the 0. So I need to go to software and set that as a 0. Okay, so I position my tool on 0. So I need to come here and tell the software that's my 0. So reset, you can see. Okay, so I did that, so that's my 0 position. Just to show you how, just to show you that 0. So I'm gonna move the tool somewhere else and then ask it to go to position 0, 0. So I moved the tool somewhere along the PCB, and now I'm gonna send. I'm gonna give you an instruction to go to position X0 and Y0. I came here to this bit here and I wrote G00, X0, Y0, and this is a G-code command which tells it to go fast to the X equals 0 and Y equals 0. So when I type enter, and you're gonna see that how the tools go to that position. So I'm gonna type enter now, and you're gonna see the tools go to position XY00. Okay, that's my position. I'm happy with that. To set my 0 now, I need to lower the tool a bit, slowly, on the slow speed, and move this piece of paper here until. Okay, now stop. That piece of paper is stopped moving, so that means that's roughly is my 0. So I need now to go to the software and set my 0 on Z-axis. So come to the software here, and where is Z? With my Z, I'm going to reset to 0, and you can see it's reset to 0. So I'm happy with it. I set my 0. I turn on my spindle, and I'm ready to go. And now I come to my software and make sure that the file is rewind, sorry, and now I'm gonna press start cycle, and you can see the machine start drilling. So now start doing the drilling of the 6 holes. The machine now finished drilling the 6 holes, so I just need to move the tool away. So I need to move the tool away from my PCB. I could have done that in the to the program, or just come here to the send CNC G code and just type in G00250, and the machine goes somewhere and it stopped. So the machine drilled 6 holes as it was programmed to do. Now I'm going to use the 6 screw of the 6 hole to hold the PCB to this wooden area. So as you can see, I secure my PCB to the wooden board by using this screw. I mean, you can use your own arrangement, you can use just a clamp, but the important part now is I need to connect this wire here, make contact. So I secure this wire to the PCB with this screw, and the second wire, which is this one here, will be connected to the tool, not this tool one, but the engraving tool, and this is going to be used to probe the surface of the PCB, because the height is not equal. If I set 0 here, at some point it will be maybe down 0.3 mil or plus or minus 0.3 mil and so on. So the height all over the place is not the same, just different of millimeter, half a mil I think. And then this probing mechanism, what he's going to do is going to go around and probe the heights, then adjust the G code, the original G code, to the new height, so we can have same, when you start engraving, you can have the same depth all over the PCB. We need to do that. This is very simple circuit. This is like just a switch. When the metal part, when this one goes down, touch this one, tell the machine that he hit the copper, so that's at 0. So the machine will register that, and you go to the next position, and we'll do that all over before you start the real engraving. So you will see that in time. But now I need to change the bit, because I got to have the drill bit, but I need to put the engraving bit, which is a V-shape bit. So I'm going to be using this kind of engraving bit. This is at 10 degrees 0.1 mil, and this is 30 degrees 0.2 mil. So I'll be using, for this application, maybe I'm going to go with the 30 degrees 0.2 mil, because I used it already. So I put this back here, and I'm going to mount this in on this spindle. So I changed my drill bit to the engraving bit, but be careful when you this, because it's a bit sharp. It's not very sharp, it is sharp, and you can get a stink with this one, so be careful when you're doing it. And so I changed it now, so I'm going to move to the next stage. You need to test your probing function if it does work. So you need to do a dry test. So connect this wire here with the crocodile clip to the engraving bit or the drill bit, and then you got this second wire. So when you touch it here at some point, when you activate the probing bit and it comes, and when this touch here, you should go back, so tell it that the copper has been reached, the conductive side is being reached. So I need to do that, so I'll show you in a second. So you go to the software, so you come to the software here and you press this button here and start the probing. So when you see your drill going down, then stop. When you touch the second wire, that means it's working. So we'll do that. We'll do that demo. So you're going to press on the button on the software, and now you're going to see this going down. And when you touch it, you go. The probing is working now. So I'm happy with it. We do it again. I'm pressing the button. Okay, that just to make sure that this is working and it's not gonna damage our tool. So after testing my probing is working, so I put this wire back here, and you will have the same effect when the tool hit the copper, the PCB copper, the conductive part. It will stop and it will register that as a 0. So you load up your G-code file for the engraving. It should look something like that as a top G-code. So this is what the path, you can zoom into tool path, and this is what it's supposed to do. But because, as I mentioned before, because the height is not 0 all over the PCB, there is another software which is third-party software. When you load up your file to the UC CNC, at some time it be loaded up to this auto leveler. So that the software responsible on doing the probing. So you see these dots here. So you will see that the machine, before start doing anything, it will go here and start probing at this point here. So it will have a general idea about the height on all these points. Then it will modify the G-code and generate a new G-code, taking in consideration the height. So you do a calculation and you will know exactly the Z0 for each position. So to do this, what you need to do, you can kind of modify or modify the G-code. So as I just mentioned before, this is what I call it auto leveler, which is done by a chap. I got in touch and he sent me this G-code. So create the G-code, and as you can see, so he's loading back the new G-code, and this G-code will involve two functions. The first one, you will do the probing, which is this red one, and then you will start doing the engraving part. But before we do that, we need to modify the G-code a bit, because we want it to stop when you finish doing the probing, then wait for us until we ask it to start again, because the probing we're going to do it without the spindle running. So we need to stop at that. Then when we're happy with the probing, we turn the spindle and the engraving start at that time. So this is a folder. We have our G-code, and this is our top G-code. This is a folder before we did the probing, before we run this software, before we ask it to do this. Then we're going to see how the folder will change. You will create a new folder, new G-code file, a modified G-code file. So as you can see now, there is a new file. It is this one. This file has been created by this software here. This is another software, as I said. We need to go to that file again, open it, select from, say, just text file, and we'll be looking for I think function M0. So the easy way to do it is just go to the top and Control H and say type M0 or M2. Okay, so that third-party software, we add the code M0. We tell the machine to stop or to pause or something. But this CNC software, it accepts the machine the code M2 instead of M0. So you need to change this to M2. So M2, and if you want, you can add as many M2 as you like when you want it to pause for a bit until you hit the circle start again. So I will change the file and I'll come back in a sec. So we changed the we add M2. You can add as many M2 as you like. M2 just to tell the program to pause. So I add M2 here. So as you can see here, I have one here, and then go down a bit. This is all the program parameters. Where is my program? So I'm going to do, so somewhere here there's another M2. Yep, that's one here. That's one here, and it's going to stop here. Then you need to turn on your spindle on again. Then you will stop here, and then hit cycle again, and the real thing start from here actually. If you can see the difference, this bit here, you just go around and get the height and store in this variable, and then it will be used in the second section of the program. The height of the variable will be calculated here, and then the Z is going to go to this position. So if you look back at the original program, I've got only this code with a fixed Z, 15 mil, but the new one is modified one. What is it? Modified .g code. Yeah. So is calculation done to get the new Z. So after changing this program or this code, you need to load it up again. So and just in case, just wait a bit. So it's loading it up. So you can see the tooth path. At the same time, double check that you got the M2 somewhere. Yeah. So you got your M2 here. So you know the changes that you made are in this version of the software. Because you reset your because you moved this board from the original position, and we got new drill or new bit, so we need to reset our 0. So I'm going to do this. I just set the XY00 just a bit farther, just down here, the screw, just a bit, maybe 2 millimeters in both axes away from this screw here. Now I need to come here as I did before, so I will reset my 0 and reset my Y, and then I'm going to do reset the Z, but I need to adjust the Z axis before I do that. So I'll be using the same technique, a piece of paper, and then move the just going a bit up in speed so I can move forward a bit fast. Yeah, so I'll move it, and then reduce the speed now and play with the arrow and moving the paper until you stop. until stop moving. Okay, I'm happy. So the paper stopped moving. Now I know roughly, so that's my Z0. So I'll come to my software again, and as you can see, I press on Z. So I set my Z to 0 in that position. So I'm happy with it. I can position my my tool anywhere. I just double check again. So I got my wire connected. For the probing. I got this one connected. I checked it that the probing is working, and now I'm gonna do now. I'm gonna hit start cycle on the software, and the probing section of program will start. So everything is already. Just make sure to rewrite my file. So I've got everything set. So I'm gonna hit start cycle, and be careful, and also always have a hand on the emergency button in case anything goes wrong, so you can stop everything. So now it's gonna do the probing section. So I'm ready to hit. Okay, so that's what it does. So it's gonna go around. It's probing the height every I think 10 millimeters, and you set that height in the software, and that height will be used later on to recalculate the new Z or the new 0 for Z. So that's what it does, and this can take a time depending on the size of the PCB. So for a small PCB it's going to be quicker, but for a big PCB it's going to take a time. So imagine you have to swipe all over the PCB, and you're going to do it automatically, kind of thing. So as you notice here, is doing the probing in steps, I think of 10 millimeter each. So each time, so that's in your position, you go down. When the tool hit the copper surface, you go back up, and so on, you move to the next position. So by doing this, you will calculate the Z equals 0, or the real Z equals 0. If the surface was, if the Z0 was all over the surface uniform, we didn't need to do this, but we couldn't achieve that. So this software resolved this issue, and the spindle is off. So we will do that. You will go all around that by step of 10, get all that around that, and up to here. Then it comes back here somewhere. I think he will, and when he hit the M2 software, it will stop. The M2 copper, it will stop. The M2 command, it will stop until we hit back the start cycle starts. So it's going to take a while to do this thing. As you can see here, the probing function is terminated here, it's finished, and the machine is not doing anything because there is the M2 function command which tells it to stop pause. So we need to turn on the spindle, and then we hit start again. So we come here. First of all, we need to take this. We need to take this wire, because we're gonna take this wire off. Then turn on the spindle. It's a bit noisy. So after turning the spindle, we resume the operation. So enter again. It goes to enter again. Right. It comes to enter again and stop. And we need to press it again. And now the job started, and now the engraving is started. as you can see. And doing it, machine doing the graving. So the machine is doing the engraving now. As you can see, it's going around the tracks and isolate them from the rest of the copper, and this is the path where it's going to go. So sometimes they start in order, but sometimes they start randomly. So you might do this one here, then go somewhere, then come back to this one. The machine is moving about. The machine is engraving now. It's a bit noisy. You can see a bit of job has been done already. You see this bit here. You can see here the Z is not always as it's supposed to. It's supposed to be minus 0.15, I think, but it's changing, and this is due to the height is not uniform all over the PCB area. This has been thanks to that software, the third-party software, so there is an adjustment made accordingly. But when you look at the depth, the final finish, the depth is the same everywhere on the PCB, and you can see the X and Y position moving, the Z position, can you see it moving again? I'm using the spindle, and I've been told that you cannot leave it running more than 15 minutes. It's just an entry level with this stepcraft CNC machine, so you can get another stronger one. You can be running all the time, but what I'm doing now, around 15 minutes, I pause the job, I turn the spindle off, I give it 2-3 minutes for it to cool down, then I put it back on. The tool is moving slowly. It's a bit noisy, I have to say. But yeah, I'll just have to be patient. The height I calculated here, as you can see, supposed to be, for example, fixed value here. But I use it as a variable. That variable is being calculated from the previous stage when you were doing the what you call it, the probing. I haven't got much left. The green one, the part I already done, and the blue one, the one I haven't been done yet. But the tools is going around them doing them, so I've got 1, 2, 3, maybe 6 or 7 left. I need to pause the job at the moment. I paused the job at the moment. Now I need to turn the spindle off. So I turn the spindle off just to let it cool down a bit. Then when I'm ready again, I'll give it maybe 2 minutes. When I'm ready again, I'll just come back, turn the spindle back on. So I gave it 2 minutes to cool down a bit, so I'm going to turn it back on. Then what I'm going to do, I'm going to resume the job by pressing this. I think we're nearly there. So come back when it's finished the engraving. Now it's finished. We've got and go back to the position just to clear up the area so I can have a look at it. The job is, as you can see here, all the green tool paths have been done, so the job is finished. Now we need to turn the spindle off. So turning the spindle off is a bit noisy. So I will turn the spindle off. It's a bit noisy. That's the engraving part. Now we need to do the drilling part, and we need to do the cutting. As we're going to do the drilling now we need to load up our file. I think we got for this job I got two files. One to do the 3mm size drill, and then to do the rest of the size. So load up this first. And this is all the hole is going to drill. So I'm just going to use I think 1 mil to do all this hole. So I need to set up my spindle for my machine to do this. So I need to change the drill. Now I put the drill bit. These are nearly 1 mil. Now I don't need to reset the X and Y coordinate, but I need to reset the Z. So I put the drill bit in the spindle. I don't need to reset the X and Y to Z because I already set, but I need to reset the zero, the Z, the zero for the Z, because I changed the drill bit. It is important not to turn off the CNC machine or make any changement, because for continuity, for the whole drill to be in the right place, there has to be kind of continuity between the two jobs, the engraving jobs and the drilling jobs. So I'll do the same thing that I did before, lowering the Z tools and checking if this is keep moving. Do it slowly, so I reduce the speed, and then I reduce the speed, so nearly there, bit by bit, until I feel this is not moving. Still moving a bit, I can pull it left and right. Now I feel it stuck now, so that's my Z0. So I got my new Z0 here, so that's 0, so my new Z0. I don't need to do any probing for this for the drill, because I just need to drill through the PCB, and half a mil or up to mil, it doesn't make any difference to me. So I'm just gonna load up directly the file, then turn the spindle on, and then start the job. You see that? And then the machine starts drilling. I certainly do to go down to 3 mil, so that's going to cover all my other PCB. And here you can see the path. So that's a hole, that's a second hole, and that's the third hole, and so on. This will do it now, still drilling, and take a bit of time. So it will take a bit of time before the job is finished. So we come back when it's about to finish. This is the last way. I've been told on to go back to position 1250, and now it's finished. Now we can turn the spindle off. So the hole are drilled. I think we still got the mounting hole to drill. We need to change the drill bit to 3mm drill, to 3mm size drill bit. As we change the drill bit, we need to reset again our Z0. So using the same technique, we lower the bit down and remove the paper. Okay, now the paper is not moving, so we're happy with that. Then we need to come to the software and set 0 on the Z axis. So we come into the 0Z and the Z, and we 0 that. So now this is our new Z. Now we need to load the second file for the mounting hole. So that's why I call it 3mm drill. As you can see, there is 1, 2, 3, maybe 6 mounting hole on this for this PCB. So we're going to turn back the spindle, then start the job by pressing on start circle. And now the machine is going to do including the mounting hole on the PCB. Turn this switch. And now the job is finished. So the machine is going to retract to already set it in the program. So we turn the spindle, and the job for the drilling the mounting hole is finished. As you can see, the mounting hole has been drilled. Now the final stage is to cut the PCB. So we mounted the end mill, 3mm end mill bit. We need now to reset the Z to 0. So as usual, using this paper. As we said before, you need to reset the 0 position for Z. So keep going down and moving this bit. Okay, now we are happy with it. So we are going to load the border cutout file. We're going to start loading the first file, which is going to cut 0.2 depth. So that's what that's the first file. We turn our spindle on. Spindle is on now. And now we're going to start our program. In some places, for some reason, feeling it. Use the speed a bit. We're going to load the second file, so 0.4. So we're going to start the job again. finish. It took us nearly 1 hour and 37 minutes, not counting the breaks, so sometimes I needed to pause it to do some other stuff. That's how it took us nearly an hour and a half to finish the job. So that's the final PCB. You might need to check it out using short circuit test with a buzzer to test that the tracks are completely isolated from the rest of the copper, and in some places, if it's not, just need to use like a very fine what do you call that, sandpaper, and you just go over it.